So it does have a common core. Common core really is G for geometry, CO congruence. It is 10, and it is proving theorems about triangles, okay? That's our common core. G for geometry, CO for congruence, 10, proving theorems about triangles. So to construct the circumcenter, what we need to do is the perpendicular bisectors of each side, okay? We're going to construct it, okay? Now, perpendicular bisector means it's going to be at 90 degrees. It will not necessarily go through the angle. And you guys have seen that. So I'm going to do my little construction. I'm going to put on C and I do my little above and below. Above and below. And then I do it on A, above and below, right? And the 2 points I have just created now are going to create my bisector. So I'm going to draw in. And this is a perpendicular bisector, okay? I know that side's equal to that side. I'll do the same thing on BC, but I like to turn my triangle. Makes it easy for me to do it. I turn my triangle. Okay, I'll do the same thing here. I'll do my above and below. Above and below, right? Above and below. Okay, and again, I get 2 points of intersection. I'm going to draw in the line segment, which is also the perpendicular bisector, okay? Perpendicular bisector, so this side's equal to this side, right? And then finally, I will do AB. So I turn it around. I'm going to do AB. Take my compass above and below, right? Little sound effects. And I do another. Okay, and then it should go through here. So what I've done is perpendicular bisector. What I've done is I've actually found the center. I've found the center of a circle that goes around the triangle, okay? I found the center, that's why it's called the circumcenter, okay? So now I'm going to adjust my compass so that the center of my circle touches my triangle. So I'm going to bring it in, touch there, there, and there, and I'm just going to then draw in my triangle, okay? So draw in my circle, draw my circle, draw my circle, and sure enough, I get a circle. So I found the center of my circle. I drew my circle, right? I'm going to call the center of my circle P. So this is point P. What I know about any circle is the radii of every single circle. All the radii have to be equal. So that's where we get this little theorem. We get PA is equal to PB, right? Which has to be equal to PC, okay? So what's our properties? Well, first of all, we know that AP is equal to BP, which is equal to CP, okay? All right, everybody got it? Now, you ready to turn the page? I'll wait for you. You're still working, okay? So, perpendicular bisector. So we've got really 3 things going on. We really have 3 things. 1, we've got perpendicular lines, right? 2, we have equal sides because we bisected each side. So we actually have equal sides, equal sides, equal sides. And 3, then we have the radii of the circle we drawn are all equal, okay? Now the book doesn't show this, but once you do the construction, it seems really obvious why AP and BP and PC are equal, because of the radii of a circle I just drew, okay? Now, you ready to turn the page? Thumbs up. Okay, let's turn the page. So on the back page, we can do it with graphing, all right? So A, let's do it. A is at -1, 6. 1, 2, 3, 4, 5, 6. There's A. 3, 4. 1, 2, 3. 1, 2, 3, 4. There is B. Okay. And then this time, we don't want to do, just a perpendicular bisector. Oh, never mind. We're not even doing anything fancy. This is going to be easy. This is just a plain old perpendicular bisector. All right. Draw it in. Okay. So if I'm doing a perpendicular bisector, 2 things. Bisector needs to cut it in half, right? So let's see. Down 1, 2, 1, 2, 3, 4. So the midpoint absolutely has to be there. Let's call that M. That has to be midpoint. Take a journey down 2 over 4. Midpoint is half the journey down 1 over 2. Okay, everybody got the midpoint? Thumbs up. Thumbs up, Jaden. Did you guys get the midpoint of that? Okay, that's easy. Now, if it's perpendicular, it's probably going to be this line right here, right? Perpendicular line. So, what do I know about a perpendicular line? Perpendicular, it's going to have the opposite slope. Okay, if it has the opposite slope, we're going to go, instead of down 1 over 2, we're going to go up 2 over 1. So the line I'm looking, up 2 over 1, 2, 1, 2, 1. Let's draw that in. And there it is. Now, there it is, but what's the equation of it? There's my line. The red line is my perpendicular bisector. It cut it in half at 90, right? Perpendicular bisector. It cut it in half at 90. But what's that equation? Well, equation of any line is sum y equals mx plus b, right? Am I going too fast or am I okay? Okay. So the red line is my perpendicular bisector. I want my red line. Okay. It's going to be my up 2 over 1, up 2 over, so it's going to be a y equals 2 over 1x plus, right there, 3. That's my answer. Okay. So we're going to do page 311, 3 to 5, 12 to 15, and 33. Questions? Okay. Let's take your book. Oh, no.